All right, everybody. Here's hoping I don't sneeze this time. But let's start talking about secondary pollutants. So, just to review from the last time when I wasn't sneezing so crazy, I had mentioned that primary pollutants are things that we pump into the air. These are things that we actually put into the air via sources such as combustion or fossil fuel burning, which is combustion, or other human activities. Secondary pollutants are things that actually form in the air. There are things that actually form chemically in the air from primary pollutants. A key secondary pollutant is ozone. Um, Ozone, if you've ever been near a copy machine and you kind of get that sweet smell from it. Ned Flanders in The Simpsons talks about how he can't write copy machine off on his taxes because he loves the smell of it. That smell is actually ozone. That smell is actually ozone. Ozone itself is not emitted. It is not a primary pollutant. No, it's a secondary pollutant. And the reason why is because it actually forms in the atmosphere. Other things get pumped into the atmosphere, other things get added to the atmosphere. Sunlight reacts with those other things to produce ozone. Now, don't worry, I'm going to talk about those other things in a moment. Typically, ozone is low in concentration at night, early morning. It's higher in concentration in the afternoon, and then lower again at night. And I'll explain why in a moment. Ozone is actually a pollutant here near the surface of the Earth. That's different from higher in the stratosphere, where it's actually something we want and we need. Down here near the surface of the Earth, it's actually problematic. It can cause health issues, it can cause respiratory irritations. It ends up being a part of what's called photochemical smog. That being said, in 2008, so about 12, 13, 14 years ago, depending on when you're watching this video, in about 2008, the Environmental Protection Agency here in the United States lowered standards of ozone from 84 parts per billion to 75 parts per billion. Basically, the purpose for this was ozone concentrations have been problematic. And so in order to determine, or in order to get people to reduce their ozone, in order to reduce the amount of ozone in the atmosphere, pollution standards were lowered. I'll talk about that in a moment. So, ozone is a key component of photochemical smog. Photochemical smog occurs when you have NOx, that's nitric oxide and nitrogen dioxide, reacting with volatile organic compounds, those free radicals in the atmosphere. Those two things react with oxygen and sunlight to produce photochemical smog. The way that it typically works is in the morning, cars get on the road. As cars get on the road, pumping out nitric oxide, nitrogen dioxide, volatile organic compounds, things like soot and black carbon in terms of aerosols and particulate matter, and they're also pumping out these different gases. During that time, the sun is getting higher in the sky, incoming solar radiation is increasing. Well, what happens is, at a certain point, that solar radiation reacts with nitric oxide and nitrogen dioxide, with NOx, and these volatile organic compounds to begin to split them up into atomic oxygen. Like so. You take nitrogen dioxide and you add solar radiation to it. That solar radiation knocks off an oxygen molecule, or specifically an oxygen atom. Then that oxygen atom combined with some kind of free radical molecule, we're going to use the symbol M here for this, reacts with molecular oxygen, O2, to then produce ozone. That ozone then actually reacts with nitric oxide to produce nitrogen dioxide and oxygen. And the cycle is actually constantly occurring. The cycle is actually constantly occurring. So nitrogen dioxide reacts with solar radiation. That solar radiation splits off an oxygen atom. That oxygen atom then gets added to another oxygen molecule, an O2 molecule, to produce ozone. Sunlight then breaks that ozone off. That oxygen, that third oxygen molecule, or I keep on saying the third oxygen atom, then actually goes back to nitric oxide to produce nitrogen dioxide. And so that's how this whole process occurs. If there's sunlight present, this nitric oxide or this nitrogen dioxide will actually break back down into nitric oxide and ozone again. So if there's sunlight present, basically what you're going to end up getting is you're going to end up getting a cycle that is just constantly happening. And so basically what you end up getting is nitrogen dioxide plus oxygen plus sunlight gets you back to nitric oxide and ozone. Then that breaks down again, sunlight reacts again, creating nitric oxide and ozone. And this process just keeps happening. This process just keeps happening. Basically what happens is if the sun is out and if there's enough nitrogen dioxide in the air, you end up getting lots and lots of ozone. Lots and lots of ozone. Lots and lots of ozone. And so basically what you end up seeing every single day, ozone concentrations bottom out in the morning. Then cars hit the road, they start pumping out NOx, nitric oxide, nitrogen dioxide. The sunlight reacts with that to then create ozone. And so ozone then begins to go up. Ozone concentrations begin to go up throughout the afternoon. And then they peak mid-afternoon and then begin to go down again. In the EPA, what is the Environmental Protection Agency? Let me get rid of that thing that I drew. The Environmental Protection Agency has standards in place that state that in order for air to be good air quality, in order for it to be what would not be considered polluted, you need to have 75 parts per billion or less in ozone over an 8-hour average period. And at most 120 parts per billion for a 1 hour average period. Anything more than this is considered unhealthy. Anything more than this is considered unhealthy. So this is how the Environmental Protection Agency defines bad air quality versus good air quality. And, oops, sorry. And this map right here shows the number of unhealthy ozone days during the year 2013. This was taken from our textbook. And I've actually tried to look for a more updated figure and haven't been able to find one. So 2013 is what we have. And if you actually notice, it's mostly urban areas that are getting the largest number of unhealthy days. Places such as I'll highlight a few here really quickly. Let me change the color here. So here's metropolitan Southern California, LA, Orange County, Riverside, San Bernardino County. Lots and lots and lots of pollution here, one of the most polluted places in the entire country. Over here, you have Dallas, Fort Worth, Texas. Big little, or a big pop-up of unhealthy days there. Over here, Houston, Galveston, that area, very oil-rich area. The Central Valley in California, lots of trucks go through there every day. Lots and lots of pollution. The Bay Area, specifically the East Bay, pretty highly polluted. The Sacramento, Chico, Redding, also very polluted. And then a few other places. This is Birmingham, Alabama, Atlanta, Georgia, the megalopolis that is New York, Philadelphia, Boston. Oh, Boston's up here. Boston's like right up here. But the number of unhealthy days is most common, is highest in areas that are highly urban, or that are highly urban. Some places are more prone to it than others. There's a reason why SoCal, Southern California, is more prone to it than a lot of other places. Now, the good news is that the actual number of unhealthy days has actually been declining over the past roughly 40, 50 years. And that's because of clean air laws that have been put in place. That's because of clean air laws that have been put in place. There used to be a time where ozone was actually a really, really big concerning thing, but it's become less and less concerning. However, we still have many, many days where we still are getting pretty high levels of ozone, to the point where we are still overtopping that level, overtopping what is considered the ozone standard. So these are the days that would be considered unhealthy. And Los Angeles, one of the most polluted places in the entire United States, and I'll explain why in a future video, is one of those areas that has seen a notable decline in the number of unhealthy days.